The disc brake system on your Taylor rig is designed for simplicity, ease of operations, and low maintenance. Much like automobiles, disc brakes are becoming more and more popular with new rig owners. Like any new technology, proper understanding of the brake system is a key factor in achieving maximum rig performance. This video is designed to familiarize operators and maintenance crews with the basic technology of the system components, and on the proper operation and maintenance of the system. The brake system is comprised of three main components: the disc, the caliper, and the actuator. The brake disc is a 42 to 60-inch ductile iron disc. It is specifically designed and machined for high temperatures and automatic pad cleaning. The disc is centrifugally cooled via air ducts casted into the disc. As the disc turns, the fins pump cool air through the disc, providing cooling. The disc is designed to run at temperatures in excess of 250 degrees. The caliper is a bronze casting mounted directly to the drawworks frame. The assembly contains the brake pads, brake application assembly, and the emergency brake system. All brake adjustment is done at the caliper. The brake actuator is located on the operator's console. This is the valve which controls the amount of air introduced to the caliper. The more air pressure applied to the caliper, the more braking power is provided by the caliper. The disc brake system is a simple air-operated system. As the operator depresses the brake actuator handle, the actuator sends an air signal to the relay valve. The greater the signal pressure from the actuator, the more the relay valve opens. The relay valve controls the amount of air pressure applied to the calipers. Each caliper has an air chamber, just like the brakes on the rig. As the air pressure increases, the chamber pushes down on the application wedge. The wedge pushes the pads against the disc. In the event of a loss of air pressure, the system includes an emergency brake system, which will automatically engage. This system also sets the emergency brake when the emergency kill button is pushed or the rig loses electric power. Like any brake system, performance life is dictated by the severity of operation. Hook loads, block configurations, proper maintenance, and operator style can have significant impact on the pad life. Under standard conditions, as defined by the manufacturer, you should expect 6 to 12 months of brake life. The brakes will need minor adjustment periodically due to normal wear. They are much like disc brakes in your car, only they do not self-adjust. The operator will need to watch, learn, and listen to his brakes. They make a distinctly different sound when they need adjustment than they do when they're correctly adjusted. It is more like a clunk. The sound is due to the pads slapping the rotor with more travel. When the rig is delivered, the brakes are factory set to 50 thousandths of an inch, the recommended gap between the rotor and pads. This gap is critical in order for the blocks to fall or the sand line to freewheel. The brakes are out of adjustment if the gap is greater than 75 thousandths of an inch on both sides of the pads with the brakes fully released. Adjustment procedure. Step 1. Make sure the parking brake is set and all hook load is removed. Set the block in a secured position on the ground. Kill the engine at this time. You'll need the following tools for the brake adjustment: one 15/16 end wrench for the application wedge, and one 1 1/16 inch end wrench for the caging tool. Locate the caging tool on the brake pod. This is a T-bolt or bolt, depending on the model you have. Remove the caging tool from its holder and install it in the brake pod. The T-bolt or bolt must be inserted into the spring brake and tightened. This will release the brake pads away from the rotor. If the wedge is greater than 75 thousandths of an inch, you will need to adjust the brake wedge. Step 4. Loosen the jam nut on the bottom side of the application wedge a few rounds. Then tighten the jam nut on the top side of the wedge. This causes the wedge to go down and the pads to get closer to the rotor. The pad should be adjusted to within 50 thousandths of an inch of the rotor. Step 6. Tighten the jam nuts, remove the caging tool, and put it back into the holder. Step 7. Repeat on the other side caliper of the tubing drum as we just did. This adjustment will be required on a regular preventative basis. It may be weekly or monthly, depending on hook load, frequency of operation, and application. Maintenance and repair. The disc brakes are fairly maintenance-free as a rule, but periodic preventative maintenance is required. The preventative maintenance is the adjustment procedure outlined above. The pads are approximately 5/8 of an inch thick when they are new. When the pads get close to the rivets or bolt heads, it is time to replace the pads. This is done with the blocks secure on the ground and the rig in a secure state. There are 2 procedure options to complete this task. Option 2 will need to be selected in the event the pads cannot be removed with Option 1. Option 1. First, remove the brake guards. Step 2. Release the caging tool from its holder and install it in the caging port of the brake pod, causing the brakes to be released. Now remove the cotter key or hairpin clip on the shaft holding the pads and remove the shaft. At this time, remove the used bronze backing with the liner or fiber pad from the caliper. The bronze with pads weigh about 65 pounds per side. The brake pads are fixed from the factory to the bronze backing with rivets. These rivets will have to be removed. This is easily done with a drill by drilling the back side of the rivet, the bronze side. Remove the old fiber from the bronze backing and wipe down the bronze with a clean rag to get any dust and dirt from the backing. You're now ready to put new liner on the backing and secure with brass bolts. Each new liner is in 2 pieces. Some of the models will require slight modification to new liners in regard to fitting the 2 new sections of the liner. Some bolt holes will not be able to be used. These will be evident as you install the nuts onto the brass bolts. Repeat on the other side of this caliper. It is now time to reinstall the backing with new liner on the caliper rod and secure it with the cotter pin or hair clip pin. Make sure that the balance link is attached to the bronze backing. The balance link is used to keep the pads wearing evenly on the rotor. Step 9. Reinstall guards. Follow brake adjustment procedures as outlined previously on the 50 thousandths of an inch clearance between the pad and rotor. Option 2. With the block secure on the ground and the engine off, you're now ready to start this procedure. Step 1. Remove the brake guards. Step 2. Release the caging tool from its holder and install it in the caging port of the brake pod, causing the brakes to be released. Step 3. Remove the air lines from the park side and mark the hoses. Remove air lines from the service side and note which port these go into. It will help later in reassembly. Step 4. Remove the bolts on the caliper foot. There are 4 bolts on each caliper foot. Step 5. With help from a proper sized lifting device, these calipers weigh approximately 500 pounds. Remove one caliper and secure it in a safe manner. Step 6. Remove the cotter key or hairpin clip on the shaft holding the pads and drive the shaft out. Step 7. Remove the fiber media from the bronze backing just as we did in option 1. Clean the bronze backing with a clean rag and install the new fiber media with the brass bolts. Some bolts will not be able to be installed. These will be obvious as you install them. Step 8. Reinstall the liner on the caliper rod and secure it with the cotter or hairclip pin. Make sure the balance link is hooked to the bronze backing. Step 9. Reinstall the caliper on the DrawWorks rotor. Square 2 rotor and bolt down. Keeping the rotor square is very important to the long life of the brake pads. It is easily done by using some 50 thousandths of an inch shims. As we square this caliper to the rotor, please take care to ensure the distance is the same on all points in the caliper alignment. Step 10. Reinstall the caliper feet bolts into the caliper and DrawWorks frame. Tighten the bolts and check the squareness again. If the caliper is not square with the rotor, re-square at this time. Step 11. Hook up the air hoses to the correct ports, remove the caging tool, and install the guards. Step 12. Follow the brake adjustment procedures as outlined previously. Repeat this procedure for the other caliper. The brake life is substantially increased by keeping the proper distance of 50 thousandths of an inch on a regular maintenance basis. The purpose of this video is to educate our customers on their Taylor rig. We anticipate long life of the rig for many years to come. If at any time during this procedure questions come up, please call Taylor Rig. We are happy to help. At Taylor Rigs, we are your partners in ensuring the long life of your rig. Our service and warranty department is available for you if the need arises.